So at this point, instead of just using x divided by y, you can call something called division. And you give x and you give y. So what is division? Division is a method that is outside of the main. Public, static, it will give us, I know it should be a double. I'm just gonna keep it simple with int division. It takes x, it takes y. So return x divided by y. We can do that thing if you want to. A lot of problems here, because this kind of works when we want to write just a simple program that compiles information in terms of the purpose of what we're doing. And 10 divided by 5 is 2. And this is by calling the method that we just have directly. But again, here, Java, again, 10 divided by 0, that exception got provoked by line 27, and it will give it back for free because it's an arithmetic exception when you arrive back in line 12. At this point, line 12 is the responsible of crashing this program. But don't worry, I got you here right away. Arithmetic exception. Sir, ma'am, you cannot divide by 0. So you can do that thing right away by reporting immediately the exception that division has been thrown for you. Basically, it will give you a arithmetic exception when you divide by 0. How about the cow thing? Well, let's try it. Enter number cow. At this point, we not even call it. It's still crashing in line 9. And don't worry, it will be handled properly. Now, sometimes we want to crash the program somehow. For example, when you have the main that calls other methods, here we can be a little bit more creative in the method that we're trying to do. Maybe internally, we can check if y happens to be 0, then don't let Java crash it for you. You can throw a new there's a couple of libraries for free. You can check your book, illegal state exception or illegal argument exception. Illegal argument exception here. And we can provide an exception at this point saying cannot divide by 0. Please try again. Now, I want you to pay attention what's going to happen here. On line 28, we are throwing, and this is without the throws. I don't know if you recognize this, throw without the S, is that you are making explicitly a mechanism to throw an exception. It is called illegal argument exception. Now, I'm using only Java's exception here because it seems to be proper. I don't know if you notice there's another one called illegal state exception. That is also free. That means that you don't have to import anything, and you give that. So now we have an illegal argument exception. Now, this will allow us to avoid Java to give us this situation. If you allow Java to arrive to the position when Java will throw that exception, you went too far. Now, I'm not saying that you should let Java throw in that exception for you. You can definitely, then you just try and catch it. But if you just let Java doing the arithmetic exception for you, that means that you let, as a software engineer, you kind of failing a little bit, because you want to not let Java perform in those things for you, because now we're going to consider something called performance or efficiency. So we don't want to throw arithmetic exception. We want to throw something. And here at this point, we can just put exception. And instead of just printing the message here, we can just see and print E1. E1 is just an object, illegal argument exception, and we just report it immediately here. Let me clear my screen, and then I'm gonna compile this program again. At this point, if I do 10 divided by 0, we get illegal argument exception. Cannot divide by 0, please try again. So the illegal argument exception, we're reporting that someone gives you a bad argument coming from an argument from the method, and we provide it here. There's a message, there's a string that we provide here that we basically, this method division is responsible to provide. So the only thing you have to do in the try catch is catch this potential exception and print the message that whoever called it. So you don't have to do the thing that we did with Granny and whatnot. So this helps us to basically make better programs. Now, what we should use, Professor? Shall we just put it here? It depends. Sometimes you will have to create software that they already have handlers for you. I'm going to talk about that in a little bit, but Java owns a super exception family or parent, and that is responsible to catch all the exceptions that potentially can happen. That's one of the things, but there's other mechanisms that they already have a lot of different try catches. So you're only responsible to throw it. Now, sometimes you want the computer to crash it for you, but sometimes we want to anticipate. We want to prevent to go all the way down to that hierarchy, or I guess all the way to the hierarchy by just handling those exceptions. Here, what we did is that we use an if statement because we know that potentially someone will give you an illegal argument exception that in terms of division is illegal because you cannot divide by 0. We already know what happened. It's an arithmetic exception, but that's what might happen. That I'm going to create a variation of this. It's going to be called example 4. This time I'm not going to throw an illegal argument exception. I'm going to throw something more personal because we're getting tired of this. So I'm going to throw a serving angry exception. Of course, I'm just kidding here, but so you can know that I'm kind of upset. So I'm gonna save this guy and I want you to visualize the following. This will not compile for the basic reason serving angry exception does not exist. And Java is gonna tell you what the heck is serving angry exception. So we don't have anything here that corresponds to that. Of course not, but that's the reason why I'm teaching you at this point. We're going to create a new class called public class serving angry exception. And I need you to pay attention on the next thing. I'm going to extend exception. So I'm going to save this guy in the same directory. Here we're using the word extends. I'm not so sure if you remember. Serving angry exception is a exception, which basically, if you remember that there is a superclass called exception. There is a family called exception. It's a parent. And all these guys, the children from exception. So this is what we're doing at this point. We're creating a new child from exception called serving angry exception. So serving angry exception, if you don't know, that's my name. I will be an exception. So it's just to let you know that this is my contract from in Java, how you do from a class to become part of a family called exception. That is super powerful because we inherit all these attributes from the superclass. An exception. Every time you put extend, you inherit everything from this guy. So we can, one thing that we don't inherit, but we can use are the constructors. So we can create a constructor called public serving angry exception, and I will provide a string s. In order to do that thing, I just need to use my superclass constructor that will take s. Hopefully that makes sense because that's ideally what you learn from in CS1. I understand that maybe that was not the same case. So now I just create a class serving angry exception that will be part of our program. So when we create the vision, now we can throw that serving angry exception. The only problem, because it's a customizable class, I'm going to compile it. Java's telling you, you know what? There is an unreported exception. Serving angry exception must be caught or declared to be thrown. Does that look familiar? If you remember the very first example that we did with the files, this is the exception that we got when we don't put throws IO exception after the main. So this is the same situation. That means that when we create this division, you need to report or catch. And here, the proper way is that, you know what, this guy throws a serving angry exception. This method called division, it will throw, potentially speaking, a serving angry exception. This is very similar with the format that we create when we're trying to read from a file. If I save this, and I'm going to clear my screen, and I'm going to call it again, still giving you this problem, because now we're looking at a different scope. We're looking at line 12. So here, Java is going to tell, hey, you know what? This guy division, yeah, what about it? This guy says that there's a potential serving angry exception that might be thrown. Oh yeah, that's fine. No, it's not fine because I know this is my sandbox, but when we get out, I don't have a proper way to handle this situation. Oh, don't worry. If you want to handle it, we can do different things. we can create a catch that basically brings the serving angry exception E3, and then here we can do either or, because here what we did in serving angry exception, we already throw a message here. Cannot divide by 0, please try again. Oh, okay, that's fine. So what you can do here is just simply print E3 without any problem. We're just gonna extract the value containing from the exception and just report it. Check this out. Enter a number, 10, enter a number, 0, right? This will trigger when I call the method division with X and Y. And at this point, when we arrive to line 29, and in line 30, it will check the 0. It is indeed true to 0. And then I'm gonna cry here big time, say serving angry exception. I'm gonna report back serving angry back exception. And this guy is gonna come here and make an exception. So basically it will crash at this point. It will come here, visit, and arrive, because that's the exception that is gonna be handled, E3, and we're gonna report it on line 21. Check this out. Cannot divide by 0, please try again. I can give you the flexibility that maybe you don't want to catch this serving angry exception. And if you don't want to catch it, that's fine. We try the following. So I'm gonna call this guy 5. So if I try to compile this, it will give us the same problem. You know what? Must be caught, or must be tried or caught in a different thrown, right? So here, I just want to elaborate a little bit more. The worst case scenario, you can put here throws this guy. So that is true, okay? That is true. But this will for sure, you're letting Java to throw it in the very last stage of the running time. And this can run without any problem for sure, right? If we put here 10 divided by 0, it will give you this in the main. Yeah? We don't want to throw in the main, because the main basically says, whoa, the main method is crashing with something called serving angry exception, cannot divide by 0. Yes, you're notifying the user, notifying the compiler. No, is not a good way to just throw it here. So why you should put it there? Because when we teach you this part in CS1, when we're trying to show you how to read files, it was gonna be a little bit too much to ask you to do the try exception, put it in a different method, make sure one method is reading, the other one closing it. It was too much. So we just told you know what, just memorize this thing and just put the throws IO exception here. Believe me, it will work. And it worked, right? But you didn't know what was happening. Now you basically handle that situation. But if you want to do this, ladies and gentlemen, what I recommend is not to put here the exception, the serving angry exception. You can do it through here, or you can put it also here. The very last catch, you can do catch and exception. And here, something wrong happened. Sorry. So this is a message that you probably have seen lately in a message. So there's an error that when you try to do a couple things, and there was no way to basically whoever programmed this let you know what exactly happened. That's okay. To be honest, is that you cannot test all possible situations. This is impossible. You cannot test all values, all possible values the user can give you, either Granny or someone else. So what you can do, you can throw that exception, say something wrong happened, sorry, or please try again later. But we want to keep the exception at the very last stage, after we catch illegal argument exception, after we catch input mismatch exception, after we catch the so-called serving angry exception. So after we did all that thing, something might happen. Indeed, I agree with you. Something, maybe there was some problem with the compiler, maybe with the GPS, maybe with the connection, maybe with, I don't know. There was something that is out of your hands as a programmer. So you say, you know what, something wrong happened. And sometimes we can just print, instead of just putting that, we can use some method called print stack trace. So print stack trace will bring you what exactly happened, technically speaking, inside of this code. So print stack trace will give you all the tracing of something goes wrong. All right, let me run it. 10 divided by 0, and then it will give you something wrong happened. Cannot divide by 0 came from that serving angry exception. It was located in this method. It was located in this main. So it gives you some kind of tracing what exactly happened. Again, you don't really want to do this. You don't really want to disclose this kind of information to the computer user. Granny doesn't really need to know about this stuff. But yet, if you don't write good comments, you will eventually will show that to Granny. You don't want that. And that is okay for making cool projects at this point of your life. But eventually, you want to avoid to have this kind of scenarios or this kind of messages like what we got, like what I showed you a couple of slides ago. When we have something like that, this is when programmers, they just barely knew how to program. And Windows 3.1, the first version of Windows, yeah, when Bill Gates was actually designing Windows for the first time, it kind of gave us a lot of description here that, as I mentioned, it was very cryptic. It was not responsive, not very informative. And then it started to evolutionate that kind of messages as time went by. But at the same time, they're not informative. And this is what we want to avoid. Something that give us an informative situation, something that help us to recognize the problem and fix it immediately, or something at least to tell, you know what, something wrong happened. Can you please try again in 1 hour later, or maybe in 10 minutes? Maybe the internet was down. Check your Wi-Fi or something like that. Make sure you have a list of all the potential catches that you can have, and then that will make sure you handle the situation properly.